Hello guys, welcome to our channel Techzen. Elon Musk, SpaceX, and NASA have just unveiled a new warp drive Starship that is truly incredible. A warp drive, or a drive that allows a starship to travel faster than the speed of light, is a fictional superluminal spacecraft propulsion engine that has appeared in several science fiction novels. Star Trek is one of the most well-known examples, and it is the subject of ongoing physics research. John W. Campbell first proposed the notion of warp drive in his 1957 novel Islands of Space, and the Star Trek series popularized it. It is a fictitious application of the Alcubierre drive, which is a theoretical solution to the General Theory of Relativity's field equations. This necessitates a brief explanation of the Alcubierre drive. The Alcubierre drive, Alcubierre warp drive, or Alcubierre metric is a speculative warp drive idea proposed by theoretical physicist Miguel Alcubierre during his Ph.D. study at the University of Wales, Cardiff, based on a solution of Einstein's field equations in general relativity, by which a spacecraft could achieve apparent faster-than-light travel if a configurable energy density field lower than that of a vacuum could be created. Instead of traveling faster than light inside a local reference frame, a spaceship would traverse distances by compressing space in front of it and expanding space behind it, resulting in effective faster-than-light travel. Within regular space-time, objects cannot accelerate to the speed of light. Instead, the Alcubierre drive alters space around an item to allow it to reach its target faster than light would in normal space without violating any physical rules. According to Einstein's special relativity theory, solid things with non-zero rest mass, unlike photons, cannot move at the speed of light. The difficulty with a material thing traveling faster than light is that it would need an unlimited amount of kinetic energy to go at the speed of light. Warp drives are one of the science fiction motifs that let stories set on a cosmic scale get over this constraint in fiction. The notion of space warp, on the other hand, has been challenged as illogical and has been linked to several other rubber science concepts that do not fit into our present knowledge of physics, such as anti-gravity and negative mass. On the other hand, it hasn't deterred scientists from giving the proposal considerable attention. In an email to William Shatner, a well-known science fiction author and actor known for his work on Star Trek, Alcubierre indicated that his idea was directly influenced by the word used in the program, citing the warp drive of science fiction in his 1994 essay. It would take 2.5 million light-years to go to Andromeda, our nearest large galaxy. Even if humanity were able to build a ship that could travel faster than light, our options for travel would be limited. It's a lot easier now, but it is still bothersome. As you know, the cosmos is enormous. Could we, on the other hand, build a ship that goes faster than light? Harold White, a NASA scientist and the lead of the Advanced Propulsion team, was in charge of the space agency's attempts to see if a faster-than-light warp drive is viable, and if so, how can we build one? He created a model and concept for a starship that closely resembled the Enterprise from Star Trek. White directed an interferometer experiment that was intended to assess such an impact at the nanoscale. The data was equivocal, and the scientists highlighted that while a non-zero or non-confirming impact was seen, the difference may have been generated by other factors. In other words, more data is required. Failure of the experiment does not rule out the possibility of warp bubbles. It's also conceivable that we're attempting to detect them inefficiently. Nonetheless, the fact that we're still trying to figure out if a warp bubble can develop shows how much work has to be done before we can use the effect for space travel. The ship concept was more of a public relations stunt than a show of capabilities, but the ramifications of a warp bubble that allowed for fractional light speed flight are huge. The capacity to travel at 1% the speed of light would allow us to explore and colonize the whole solar system. 0.1% light speed would make exploration and colonization of Mars or the Moon considerably easier. One piece of good news is that earlier worries that the hypothetical warp drive may wipe out entire star systems have been disproved by more thorough examination of the maths. Although data suggests that this is unlikely to be a concern, boats close to a warp drive ship may still be at risk. From Alcubierre's initial assessment that planetary-sized power sources would be required to more current data that says we might build a spacecraft with a power source the size of Voyager 2, energy needs have also decreased dramatically. Could Elon Musk, the founder of SpaceX and Tesla, become a real-life Zephram Cochrane, the fictitious Star Trek inventor of warp drive? Neil deGrasse Tyson, an astronomer and a scientific figure, appeared to believe so. Tyson sent Musk a short message on Twitter asking when the entrepreneur will stop tinkering with Mars rockets, hyperloops, cybertrucks, and brain-computer interfaces and instead focus his efforts on inventing a warp drive like the one shown in Star Trek to propel spacecraft across galaxies. Sincerely, space geeks of the world, he signed it. Musk isn't about to transform SpaceX and Tesla into side enterprises. So he responded to Tyson on Twitter with a persuasive case for sticking to his core businesses. If we create a city on Mars, Earth-Mars travel will be a powerful forcing function for inventing something like warp drive. This Twitter squabble isn't going to affect Musk's course or get us any closer to a true warp drive. We'll have to make do with fantasies of SpaceX starships landing on Mars. However, it may be exactly what Musk requires in the long term to make his Mars ambition a reality. Except for cloud tops of Venus, the conditions on the surface of Mars are closer to those on Earth in terms of temperature and sunshine than any other planet or moon. Due to radiation, substantially reduced air pressure, and an atmosphere with barely 0.16% oxygen, the surface is not habitable to humans or most known life forms. Human existence on Mars would necessitate the use of advanced life support systems and constructed dwellings. Water treatment systems are an important part of this. A human being mostly composed of water would perish in a couple of days if deprived of it. Even a 5% to 8% drop in total body water induces weariness and dizziness, as well as a 10% reduction in physical and mental impairment. Humans will find Mars to be a difficult place to live in. Various technologies have been created to aid long-term space travel and might be used for Mars colonization. Many different biological processes may be badly affected by the environment of Mars colonists, according to scientists. There are a plethora of bodily side effects that must be minimized as a result of increasing doses of radiation. Gravitational differences may have a deleterious impact on human health by weakening bones and muscles. There's also the possibility of osteoporosis and cardiovascular issues. The International Space Station now rotates humans in zero gravity for 6 months, which is similar to a one-way trip to Mars. This allows researchers to have a better understanding of the physical state in which astronauts on the mission to Mars would arrive. The surface gravity on Mars is just 38% of that on Earth. The cardiovascular, musculoskeletal, and neurovestibular or central nerve systems are all affected by microgravity. Mars's global magnetosphere is weaker than Earth because it has lost its inner dynamo, which has drastically reduced the magnetosphere, the source of so much radiation reaching the surface despite its relative proximity to the Sun. This, along with the Martian surface's thin atmosphere, allows a large quantity of ionizing radiation to reach it. All this combined would create incentives to shorten travel times in spaceships as much as possible. Successfully develop warp drives or a similar piece of technology will deliver that in spades. Neil deGrasse Tyson was right. So that's a wrap for today. Thank you for watching. If you would like to receive updates about more tech-related news, do not forget to like and subscribe to the channel and hit the bell icon for more updates. If you have any questions, please share your thoughts below. Thank you for staying with us.